Okay, this is a problem from your assignment. I'm just going to change this to a 3. This is number 27. So feel free to go ahead and put this with your assignment. The first thing I'm going to notice is that it does say find the points of inflection and discuss the concavity. So I am talking about the second derivative. And this is going to take a while to do because the second derivative is going to be much more difficult to find. So my first thing I'm going to do is go ahead and write this function with a half exponent. I'm also going to take note right here that the domain of this function is going to be from negative 3 to infinity. Negative 4 gives me a negative number underneath my square root, so the only parts of this graph that even exist are from negative 3 to 0. And this could be at negative 3, because negative 3 will work, so I should have used a bracket. Let's go ahead and find the first derivative. The first derivative would be first times the derivative of the second plus the second times the derivative of the first all over, that's it. I was thinking quotient rule for a minute. What this gives me, I am going to need to combine these terms because otherwise it's going to make the second derivative very difficult. So one of the things I said that you needed to be able to do was combine like terms. This does go on the bottom of the fraction, so does the 2, and this x stays on the top of the fraction. And this one just has a square root of x plus 3. So I need to combine these, which means I need common denominators. My common denominator is going to be 2 square root of x plus 3. 2 square root of x plus 3. This one doesn't change, however, this one was over 1. So when I multiplied the top by 2 square root of x plus 3, I end up getting 2 times x plus 3. So my first derivative will be rewritten as, this is x plus 2x, so 3x, and then I have plus 6, so I'm distributing those through, all over 2 square root of x plus 3. Now, I said this was much more difficult. The second derivative now requires me to do a quotient rule. So we are going to go ahead and find this derivative using the quotient rule. Now we do want to think of this as 2x plus 3 to the 1/2 power, so I'll write that off this side. Bottom times the derivative of the top minus the top times the derivative of the bottom. The derivative of the bottom would be 1/2 times 2 would give me a 1, so just x plus 3 to the negative 1/2 all over bottom squared. Well, 2 squared is 4, and the square root of the x plus 3 squared is just x plus 3. So I'm going to come up here to finish the simplifying. The second derivative would then be 6 square root of x plus 3 minus, I'd have the 3x plus 6 on the top and the square root of x plus 3 on the bottom, and then a large fraction with the 4x plus 3 on the bottom. Well, I now need to combine like terms up here. So what that's going to give me is I'm going to want to make the common denominator be square root of x plus 3 on the bottom. So that's going to give me 6 times x plus 3 on the top, and then I'd keep my 3x plus 6. Now this is being subtracted here, so I've got to make sure I distribute my negative through. My second derivative then would be 6x minus 3x, so let's just change that to be a 3x. Then I'd have 18 minus 6. 18 minus 6 is 12. And all over the square root of x plus 3. Oh, and I lost my huge denominator. I'm going to have to finish this on the next video.